Good evening.
Good evening.
Good evening, everyone. We will begin shortly. Give me 2 minutes. I trust everyone received the email from me today. You should have gotten your homework back, and you should have gotten 3 handouts.
Mrs. Demare, did you say you forwarded the homework as well, the previous homework?
Yes. Let's see.
I got the handouts, but I didn't see the homework. Let me check again.
You are Mins? No.
Yes, sir. Yes, sir.
Okay, I will tell you in a second. Sent to Kendrick Mins at MINNS710@gmail.
Yes, sir.
You should have gotten it at 1:13 p.m. today. Please see attached graded homework.
Okay. Okay, now I see it back up. Yeah.
Okay. All right, good. Okay, so let's see. Let's bring up. You should be able to see our class notes on my screen. Do I have that up? Yes, I do. Okay. So first things first, I think I also sent you what I thought is ideal answers for the homework. Any questions or queries, you certainly feel free to email me or WhatsApp me, and we can go through it. Most people did reasonably well, at least for first homework. I do certainly want you to consider your expression, the way you justify and define your answers, because that's really where the bulk of the grade is going to come in. I was a bit generous this first homework because this is all brand new in terms of us not having right or wrong answers, not completely right or wrong answers, but I do want you to focus on making sure that your response fully and completely justifies the answers that you've chosen to give. Right? Do not presume that I'm going to know what you're talking about. You're writing as if somebody who doesn't know anything about this, and you're trying to explain to them exactly why you chose the answer that you chose. Okay? All right. Market equilibrium. Last class, we very quickly ran through the supply side of the market. We said everything that we talked about in terms of constructing a demand function, we do exactly the same thing for constructing a supply function. The only difference is that from the perspective of demand, looked at it from the perspective of the consumer as a customer, whereas the supply side of it looks at it from the perspective of the firm or the company or the merchant. And so that really is the big difference. Apart from that, everything else pretty much works the same. Now, what we wanted to do, though, is begin looking at, we looked at demand for goods or services, look at the supply of a good or service. We wanted to put those together and look at the market as a whole, right? Market equilibrium. How do we put demand and supply together in such a way as we come up with one single unique price, and at that price where demand for this product is exactly equal to how much firms wanted the supply of this product or service. All right, so let's start with our definition. Market equilibrium is defined in this way. 3 criteria would have to be satisfied for us to consider there to be market equilibrium. The first is that quantity demanded must be exactly equal to quantity supplied, such that there's no pressure to price. There's no pressure for prices to change. And that last phrase is important, and we will discuss it, not this class, but certainly in subsequent classes. All right, first things first, quantity demanded must exactly equal quantity supplied, such that there's no pressure for prices to change. The second criteria is that for there to be market equilibrium, all viable transactions that can take place do in fact take place. So there's no situation in which somebody wants to transact. You have somebody wants to sell a product and somebody wants to buy that product, but somehow that transaction doesn't occur. Right? Market equilibrium says that for our market to be in equilibrium, such cannot be the case. All viable transactions that can take place does in fact take place. And finally, market equilibrium occurs when A and B can happen without government influence on the market. Right? We in our market-based economies are very firm in believing that government messes up everything they put their hands on. So we would like the government to stay the hell out of our business whenever possible, including the market. Right? We think that government should not be involved in influencing our decision on what to buy, influencing firms' decision on what to sell. All government should do is make sure that there's no hanky-panky going on. Apart from that, the government should just stay out of it. Don't influence the market. So for us to have market equilibrium, we said, one, quantity demanded must be equal to quantity supplied, such that there's no pressure for prices to change. All viable transactions that can take place do in fact take place, and there's no government involvement trying to influence the market. And we will see how this works out as we go along. Right? So how are we going to determine whether a market is in equilibrium? We're going to do it two separate ways, and I've sent you handouts for these. The first is graphically, just looking at the graphs. Right? Using the demand and supply curves, market equilibrium can be determined as a point at which the two curves intersect or cross. Right? So a vertical line from the intersection of the two curves will tell us where the equilibrium quantity is, and a horizontal line will tell us where the equilibrium price is. Now, the best way to do this is to actually see it. Right? So these two curves should be familiar to us. The demand curve, we've gotten this demand function because we've seen it a lot of times so far. This is the only demand function we've seen in this class. Qt equals 20 minus 4p. And we've derived that from our demand schedule, if you remember, if you go back through your notes. And similarly, is that line crooked? Maybe it is. We have derived our supply curve from our supply schedule. And we took our supply schedule and we graphed it, and we got this supply curve. We took our demand schedule, we graphed it, and we got this demand curve. Right? We said the demand curve is downward sloping because of the law of demand. At higher price, fewer items will be demanded. And as price falls, people will want to buy more and more. We end up with a downward sloping demand curve. On the other hand, we end up with an upward sloping supply curve because of the law of supply. The law of supply says that if we can't charge a price for it, we're not going to stock it. We're not going to keep it in our store, in the warehouse. We're not even going to bring it on the island. So therefore, our supply curve will always start at the origin. where P equals 0 and Q equals 0. And as the price rises, we're willing to add more and more of this item on the shelf because we can get more and more for each item that we sell. So as the price rises, we want to supply more to take advantage of these rising prices. On the other hand, as price falls, we want to supply less and less of this item because we're getting less and less for it. So we end up with a demand curve that's downward sloping and a supply curve that's upward sloping. We can put these two curves on the same diagram, and we have this one that's in the middle. We have our demand curve, downward sloping, QD equals 20 minus 4P, and our supply curve, upward sloping, QS equals 4P. And we said, a vertical line from the intersection of the two curves. So we see where the two curves cross, and we drop a line straight down. A vertical line from the intersection of the two curves to the horizontal axis will indicate equilibrium quantity. An equilibrium quantity we refer to as Q star. An equilibrium quantity is a point at which quantity demanded is exactly equal to quantity supplied. Right? So here I've made a diagram much bigger, and we said we look at where our two curves cross, and that's at a point Y, and we drop a perpendicular, a line straight down to the horizontal axis. And where it touches that line, that is our equilibrium quantity. That's our Q star. And that's why quantity demanded is exactly equal to quantity supplied. We also see where the two curves cross, and we draw a horizontal line across to our x-axis or our price axis. And where it touches that axis is what we call our equilibrium price, or P star. And this is the only point at which those two lines cross. So it is a unique point. There's no other point on our graph where those two curves cross. So it's the only two points where both the demand is exactly equal to supply. So practically speaking, it tells us that it's only at this unique price P star that quantity demanded is exactly equal to quantity supplied. So if we want to determine market equilibrium by just looking at the graph, we see where the two lines cross. We draw a perpendicular line straight down to see where it touches the horizontal axis. And then we draw it across to our price line, and that's going to tell us the price. That's how we do it, just by looking at the graphs. The problem is that it's kind of hard to put any numbers to this. You know, we said, okay, we can see that the lines cross a certain point, and if we draw it really, really, really carefully, and if we put our numbers really, really good along our vertical axis and along our horizontal axis, we may possibly come kind of close to the real value, but really we would be guessing. To get a precision level of our Q star and our P star, that's our equilibrium quantity and our equilibrium price, we need to do a little bit of mathematics. Right? Nothing too deep, nothing too heavy, something that we all can manage, you know, without straining our brains. So what we want to do is, how do you go about determining market equilibrium mathematically? So because both the demand curve and the supply curve have their functions associated with them. Because remember how we got these curves. Right? We got the demand curve by taking the demand schedule and plotting it. And we also saw how we got the demand function. And we found that the demand function is just simply a mathematical expression of our demand schedule. So we can say that the demand schedule, the demand curve, and the demand function are just three different ways of expressing the same information. The demand schedule is a list of prices. The demand curve is taking that list and graphing it. And the demand function is taking that list and creating a mathematical function from that list. So in essence, we can say that our demand function perfectly describes and defines our demand curve. In mathematics, we tend to put this in quotation marks, so you make sure to put the quotation marks in. And what that means when we say something perfectly describes and defines it, it tells us everything that we can possibly know about this demand curve. This function, this demand function, would tell us where this curve touches that horizontal line. It would tell us where the curve touches that vertical line, and it will tell us the slope or shape of that curve, how steep or how flat that curve is. This function gives us all that information. Similarly, for the supply curve, the supply function perfectly describes and defines the supply curve. So we now know that this function tells us everything about this curve, and the demand function tells us everything about the demand curve. But we also know that market equilibrium occurs when the demand curve and the supply curve meet, crosses, intersects. Market equilibrium occurs when these two lines cross each other. So we know two things. We know market equilibrium occurs when the demand curve and the supply curve crosses. We also know that each of those curves can be described by its individual mathematical function. So each curve has its own function. And if market equilibrium occurs when those two curves cross, then market equilibrium must also occur when those two functions cross. That is, when those two functions are set equal to each other. Mathematically, any two lines can be described by a function. And where those two lines cross would be the exact equivalent of those two functions being equal to each other. So in our notes, because both the demand curve and the supply curve are described and defined by their individual functions, the point at which the curves intersect is equivalent to determining a price and quantity that is identical in both equations. So to find market equilibrium, we need to find a P for our demand equation that's identical to the same P in our supply equation, and a Q in our demand equation that's exactly the same as a Q in our supply equation. Right? So we need to determine a P and a Q that's identical for both equations. Right? To do this then, so to find market equilibrium mathematically, we must find both a price and a quantity that will simultaneously solve the demand and the supply function at the same time. You may have remembered this from your high school days and hated it even back then. This is called solving a system of simultaneous equation. You take two equations and you try to solve them together at the same time. Don't panic yet. We'll walk our way through it all over again. So how do we go about doing that? So step-by-step approach. Right? And again, until this becomes second nature to us, I strongly urge you to focus on your methodology, step-by-step approach, each time you're confronted with a question like this. So the first thing you do to find market equilibrium mathematically is you set QD equal to QS. That is, you set the function, in this case, our demand function, and we look at our graph and our demand function we see is 20 minus 4P. and we set that equal to our supply function. And we see that our supply function is 4P. Right? QD, we know is equal to 20 minus 4P, and QS, we know is 4P because they gave that to us. So step one says, we set whatever we found our function for our demand, we set it equal to our quantity supplied function, and we try and solve that. So we end up, when we set it equal to each other, we end up at 20 minus 4P, that was our demand, equal to 4P, which was our supply. And we try and solve it. Since we like prices to be positive, and I already have a positive 4P on my right-hand side, I took that negative 4P and moved it over. And that's how I got my positive 8P. Now, if you're one of these people, and apparently there are a lot of y'all out there who can't work with things that are on the wrong side, in the quote unquote wrong side of the equation, you can put all your P's on the other side and that works just fine. Right? So we end up with 20 stays on the left-hand side. We move that negative 4P over and it becomes positive 4P. So positive 4P plus the 4P that we moved over becomes 8P. 20 equals 8P. We end up with P equals $2.50. You have to take my word for it. We can work at a few exercises in a moment. Right. So now we have a P, but not any P. We have found P star, equilibrium price. The one unique price that if this is the price that's prevailing in the marketplace, at that price, quantity demanded will be exactly equal to quantity supplied. That is, if the store charges this price, whatever P is, in this case $2.50 for this item, it will find that at the end of the week, it has sold out its entire stock that is put on the shelf. In addition, nobody has come into the store wanting this item and couldn't get it. Everybody who wanted could get it as long as they're willing to pay $2.50, and you were able to sell all that you wanted as long as you're willing to charge $2.50. At a price of $2.50, quantity demanded was exactly equal to quantity supplied. So once we found our equilibrium price, our next step then is that, okay, so we know at $2.50, quantity demanded will be exactly equal to quantity supplied. Now we need to figure out how much would that quantity be. So once we've determined P star, we substitute this value into our quantity demand equation to ascertain the value of quantity demanded at this equilibrium price. So once we found this one unique special price, then we go and we plug that back into our demand equation, and we solve our demand equation, and that's going to tell us what quantity is going to be demanded at that price. So we, as we normally do, we put out our equation first. QD equals 20 minus 4P. Now I skipped my box. It's not necessary, but it's a good habit to get into until it becomes second nature to you. But it is second nature to me, so I could have skipped my box. Now, look at how I adjusted my equation. My equation is no longer 20 minus 4P. My equation is 20 minus 4P star, that equilibrium price. So I'm not plugging any ordinary price into my equation. I am plugging the equilibrium price into my equation, the P star into my equation. So when I plug my P star into my equation, I end up with QD equals 20 minus 4 times 250, because my P star that I already figured out was 250. 4 times 250 is 10, and 20 minus 10 is 10. So now I know at a price of $2.50, my customers are only going to want to buy 10 units of this item. All right. So what should quantity supplied be? If quantity demanded is 10, to find out what quantity supply is, we take that same P star and plug it into our supply equation. Our supply equation was QS equals 4P. We take that straight from our graph, and now we know we're not dealing with any ordinary P, we're dealing with P star. So QS equals P star, we know P star is $2.50. 4 times $2.50, and now we know at a price of P star, firms will be willing to supply 10 units. People want to demand 10 units. Firms want to supply 10 units. Oops, sorry. So then, go back. We have found out what the equilibrium price is, $2.50, and we found out at that price, demand is exactly equal to supply. 10 units will be demanded, 10 units will be supplied. So if we have determined, so we did our calculation, and we found out that QD is exactly equal to QS, then we have correctly ascertained the equilibrium quantity. Now, when you're working these out, both on your homework and in your exam, and you figured out that, okay, my QD is different from my QS, then you did something wrong. All right. So you go back and you double check that you got the right price. And then you make sure and double check, okay, when I use that price, what do I get for quantity demanded and quantity supplied? Because if that is the one unique price, we should get this exact same amount for quantity demanded and quantity supplied. All right. We would have found a P and a Q that solves both those equations and gives us the same answer for both equations. All right. Shall we walk our way through an example? Okay. So we'll do the sample exercise, and we will look at the exercise, one of the handouts that you've gotten. All right, so San Salvador Yam Growers Association. I made it up. There's no such body, but it could be. So these people in San Sal, they grow yams, yams, sweet potatoes, whatever it is. And they've commissioned a study of demand and supply for their delicious yams and sweet potatoes. This is exactly the kind of questions you would get worded in this form. As a result, the following demand and supply functions were determined to best describe the market for yams and sweet potatoes in the Bahamas. So, as a note, they tell you all prices are in Bahamian dollars and quantities are in 25-pound sacks. That's just superfluous information so that, if you're dealing with, that doesn't mean you multiply everything by 25. So questions you'll be asked, a lot of questions. At what price would Bahamians choose not to buy any of SSYGC products? All right. How high they need to raise their price before we said, you know what, I want none of your yams or your sweet potatoes. If price was not an issue, how many sacks would Bahamians demand? And if SSYGC was charging $50 for each sack, how many sacks would then be demanded? What if SSYGC wanted to sell 50 sacks? What price should they charge? And determine a price to the nearest 25 cents that SSYGC can charge and still sell no less than 41 sacks. They got to sell at least 41. At a price of $17 per sack, how many sacks would SSG be willing to supply? I hope you notice the last word in that question. That's your clue that we're no longer using the demand equation, but we would use the supply equation. And finally, you determine the market clearing price and how many sacks will be demanded and sold. When you see it worded like that, it's going to mean find P star and Q star, the equilibrium price and the equilibrium quantity. That could be worded a number of different ways, but you need to be able to look at it and say, that means find P star and Q star. Okay, so shall we take it one question at a time?
Please.
First question is, at what price would Bahamians choose not to buy any of SSYG products? All right, at what price would Bahamians choose not to buy any of SSYG products? I put up my box, and I have not my one equation anymore, because I know I'm dealing with two functions, because the report from my accounting firm who I commissioned for this study said that here's my demand equation, Q equals 180 minus 3P, and here's my supply equation, QS equals 9P. Right, so I just want to make sure I keep those so I don't mess up and try and remember what I were before and make a mistake. So I keep repeating them, and I always put them down for my problem so I know what I'm working with. Okay. So they asked, at what price would Bahamians choose not to buy any of SSYGC products? And in my head, I know they're asking at what price. So I put a question mark next to my P. I said, Bahamians, at what price would Bahamians choose not to buy any? Not to buy any means buying none. So that made that, in my head, that means my quantity demanded is 0. Fine. Once I'm sure about that, then I put on my demand equation. Sorry, let's go one step backwards. I look at my first question. And what I'm trying to figure out, first of all, is that I have two equations. I have my demand equation or demand function. I'm using them interchangeably. And I have my supply function. As a general rule of thumb, if my question doesn't have the word supply in it, I'm probably using my demand equation. Okay, that being said, I put on my demand equation, 180 minus 3P, and I make sure I write it down because it keeps me on track. Now I plug in what I know and try and solve for what I don't know. I know from my box that QD equals 0. So I plug that in and I keep the rest. So I end up at 0 equals 180 minus 3P. Easy enough. We did this last class. We know how to do this. We know we like our prices to be positive. So we take that negative 3P and put it on the other side, and that becomes positive. So we end up with 3P equals 180. P equals 180 divided by 3, that therefore P equals 60. So I know if these fools start charging $60 a bag, a sack, yeah, they ain't getting unsold. All right. We will say, thank you very much. I appreciate the time, but no thank you. At a price of $60, Bahamians would choose not to buy any of SSYGC products. All right, fine. We've looked at this type of question before. We think we can do this again, especially if we have an example to work with. If price was not an issue, how many sacks would Bahamians demand? Again, from last time, we figured out this trick. If they tell us the price was not an issue, in our heads, we make it straight and plain. If you tell me pay whatever I want, well, I don't want to pay any. Right. Especially now, I look at the question. The question is, how many sacks would Bahamians demand? That sounds like quantity. How much quantity? So I put my question mark next to my quantity, and I put a 0 next to my price. All right. So again, first things first. There's the word supply doesn't apply anywhere in my question, so I'm thinking I'm still working with my demand equation. I put down my demand equation, QD equals 180 minus 3P. And then I'm plugging in what I know and trying to solve for what I don't know. I know that P equals 0. So in my equation, I end up with QD equals 180 minus 3 times 0. Well, 3 times 0 is 0. So I end up with QD equals 180 minus 0. QD equals 180. Now, generally speaking, I can look at my demand equation and have in a question like this, and I know I'm dealing with my autonomous consumption. But generally speaking, so once you, especially under exam conditions, you want to make sure that you don't give away points. So you stick with your methodology. You do a step-by-step approach to solving these questions. Again, we've seen this question before. This is not a big deal for us. It may take us a little practice, but we know how to work our way through these. If SSYGC wants to charge $50 for each sack, how many sacks would be demanded? Do not look at a 25-pound bag of sack and start wanting to play with the 25 that you see in the question. That ain't got nothing to do with anything. It could be a 1,000,000-pound bag of sack. It could be a trillion. All right. What we're interested in is, what are we being asked for and what are we being given? The question says, how many sacks would be demanded? So clearly we're being asked for a quantity. And it says if price was $25, so they gave $50. So they gave us a price. They gave us a price of $50. And if you go all the way back to the setup for the question, it tells you that the prices are in B dollars and the quantities are in 25-pound sacks. That just tells us the weight of the sacks. That ain't got nothing to do with how we answer the question. Okay. They're charging $50. How many sacks will be demanded? We put down our equation as usual, and then we plug in what we know and try and solve for what we don't know. We know that price is $50. So we end up by plugging it into our demand equation, because we don't see the word supply anywhere in the question. We end up with QD equals 180 minus 3 times $50. 3 50s is 150. So QD equals 180 minus 150. 180 minus 150 is 30. So we end up with 30 sacks. And if you want to be pedantic about it, each of those sacks are heavy as 25 pounds. So we end up with 30 25-pound sacks. Again, we've seen this before, but I want you to get comfortable with the notion that there are units attached to these. So again, and final question that we've seen, no, not final, sorry, that we've seen before. If SSYGC wanted to sell 50 sacks, so they've come out and they've only brought 50 sacks to this market stall and they want to sell out 50 of those sacks, what price should they charge if they wanted to not have to take any of this back with them? Okay. Again, in our box, we're plugging in what we know, and what we know is that they want to sell 50 sacks. That sounds like a quantity, and they're asking what price should they charge. So we need to find a P. So P is a question mark, QD we know is 50. We look at our question and there's no supply anywhere in that question. So we know we're dealing with our supply equation. Fine. So far, no stumble, nothing to cause a hiccup or hurt our heads. We put on our equation, QD equals 180 minus 3P. And then we plug in what we know and try and solve for what we don't know. We know that quantity, the number of sacks is 50, according to our box. So we put 50 where we saw QD. So then if 50 equals 180 minus 3P. Since we like our prices to be positive, because we've never seen a negative price in our life, we take that negative 3P and move it over to the left-hand side. That causes it to become positive. 3p. And we take that positive 50, move it next to the positive 180, and that positive 50 becomes negative 50 because we moved it to the other side of the equal sign. So we end up with 3p equals 180 minus 50. 3p therefore equals 130, because 180 minus 50 is 130. And p therefore is 130 divided by 3, which works out to $43.33333333 indefinite. But since our currency only has cents in it, we end up at $43.33. So at $43.33, they can sell all 50 of those 25-pound sacks that they brought to market. And lastly, of the questions that we've seen before, says determine the price to the nearest 25 cents that SSYGC can charge and still sell no less, or at least, it means exactly the same thing, no less than 41 sacks. So they need to sell 41, at least 41. They can sell more than 41, but they just can't sell less than 41. So we always do what we do before. We create our box. Our question doesn't say anything about supply. So we're still working with our demand equation. And we put in our box, what are we being asked for? It says determine a price. So we're being asked for a price. So we put a question mark next to the P. And somewhere in that question, they must have given us a quantity, and the quantity we see is 41 sacks. Even if we don't quite follow all the rest of the words that they throw in there, like to the nearest 25 cents and no less than, we know how to at least begin the first half of the question. So we put out our equation, plug in what we know, and try and solve for what we don't know. Our equation is QD equals 180 minus 3P. From our box, we know QD is 41, so we plug that in. So 41 equals 180 minus 3P. We like our prices to be positive, so we take that negative 3P and move it out to the other side and become positive 3P. And we take the positive 41, move it to the other side, and became negative 41. So we end up with 3P equals 180 minus 41, and 180 minus 41 is 139, unless my math is way off. So we end up with 3P equals 139. And therefore our P works out to be $46.33. Right? That is our straight out answer. Then we now have to deal with the rest of this stuff in the question. It says, to the nearest 25 cents. So the nearest 25 cents, we look at $46.33, and it means we can go up to $46.50 or down to $46.25. What we cannot do is just look at this and say, okay, which one is closest, and that's the one we're going with. Right? That's the lazy way to do it, and it's more often than not going to be wrong. Right? Because there is some, I don't know, lecturer I heard out there who tried to mess with students and make sure, put them in that position where they won't go places that they ought not to go. Right? So we have two possibilities, $46.25 or $46.50. Now we can test both of them. And here we are testing both prices to see which one meets the conditions that we've established. Conditions that we've established says that it has to be in 25-cent increments, and we must sell no less than 41 sacks. We can sell more than 41, but we cannot sell less. When we plug in the $46.25, we work it to 41 1/4 sacks. That sounds like more than 41 sacks to me. Even though it's only 1/4 of a sack more, hey, it's more. But when we plug in the $46.50, it came up to 40.5 sacks. Now 40.5 sacks is close to 41 sacks, but it ain't 41 sacks. Close, but it ain't close enough. As the old man says, close only counts in horseshoes and hand grenades. Mathematics, you need to get precise. So we know price of $46.50 ain't gonna work.
So, Mr. Demerit.
Yes, Mr. Curry.
First of all, good afternoon, everybody. But so a question like E.
Yes.
Right? How much points would that be worth?
I don't know, maybe half a point, 1 point maybe.
Why would that be worth half a point if you have to determine between the higher or lower factor?
I'm being facetious. It would certainly be worth at least twice as much as A through D so far.
Okay,
because it
so
requires twice as much work.
So in a case like that, like, okay, based off the pattern that I see, because I'm reading these numbers like so. If it says at least something, I don't want to call the lecturer name either, but I can see it to say that the safest bet is always to say round down without even doing any of the working. So what I get,
but why?
Because you're trying to get the least amount. So the best way for you to get,
because the law of demand says that when we worked $46.33, right?
Right. Mm-hmm.
The law of demand says if I were to raise my price above $46.33, what's going to happen to my quantity?
It's going to go down.
Yes.
It's going to be less demanded.
It's going to be less than, but at $46.33, what is my quantity at that price?
41.
41. So if
Correct.
I raise my price above $46.33, my quantity is going to fall below 41.
Correct. So
and I know I can't go below 41.
Okay. So if I don't show that working between 41, if I don't show the working between 46, 25, and 46.
Okay, I got where you go. Okay, yeah. I got where you go. No, it ain't making no difference to me. Right?
Okay.
You want for a homework question, you want to get all the way to $46.33. Right? To get full mark. Okay. So you show this working to $46.33. Then you can say, I would choose $46.25 as my final answer.
Okay.
And that will be entirely correct for all the marks.
Okay, perfect.
All I'm doing here is sort of walking you step by step as to why we would get to $46.25 being the correct answer. But if you're saying, okay, I understand the law of demand well enough to know that I can never, ever go up higher than the actual price that I calculated. And that actual price turned to be $46.33. I can never go higher than $46.33. I can go below it. I can go as far below as I want to go, but I just can't go above it. Any other questions? Okay, so that was what, E? F. At a price of $17 a sack, how many sacks would SSYGC be willing to supply? First time we're coming across that word. So then, all of a sudden now, we are no longer dealing with the demanding function. Because we're not asking how much would people want to buy, how much people are going to be demanding, how much is going to be sold. We're asking how much they're willing to put on the shelf. So if they only can charge $17 and they know this, how much of this item would they be willing to stock knowing that they can only charge $17 for it. The only way to do that is to use our supply equation. So our supply equation, everything else stays the same. We construct our box exactly like before, except instead of quantity demanded, we have quantity supplied. And we do everything exactly the same. What are we being asked for? We're being asked for how many sacks. That sounds like a quantity. So we put a question mark next to the quantity, which means somewhere in there, they must have given us a price. The price they gave us is $17. Everything else is exactly the same, except we're using the supply equation now instead of the demand equation. So just like before, when we put our demand function down before we do anything, we put our supply function down before we do anything. And our supply function is QS equals 9P. All right. As before, we plug in what we know and try and solve for what we don't know. We know that P is 17. We see that from the question, we see that from our box. So we plug in that 17 and we find that QS equals 9 times 17. 9 7 is 63, put a 3 in carry 6, 9 1 is 9, and 6 is 15. We end up with quantity supplied equals 153 sacks. So at a price of $17, we're willing to supply 153 sacks for sale. Does that mean 153 sacks will be sold? No. There's no guarantee of that. All we're saying is that we're willing to put it on the shelf. We're willing to stock it for sale. How much will be sold at $17 a sack is a different question. Okay, now, finally, determine the market clearing price and how many sacks will be demanded and sold. When we talk about market clearing price, we're talking about the price at which demand, quantity demanded, is exactly equal to quantity supplied. Determine the market clearing price, find market equilibrium, words that mean the same thing. Should key in your brain, find P star and Q star. And there's a step-by-step process for finding P star and Q star. Okay, the more you practice this, the easier it will become for you. But you always want to keep in mind, okay, I want to make sure I'm following my step-by-step process. So if somehow my answer turns out to be different from what he said the answer is supposed to be, either I get an opportunity to argue with him and tell him, listen, you're wrong, I want my point, or, which is much more likely, you get to see where you went wrong. Okay, so let's take it step by step for finding our market clearing price and how many sacks would be demanded and sold. In other words, step-by-step process for finding P star and Q star. First, step 1. Set QD equal to QS. I'm missing a word. Set QD equal to QS and solve for P star. And I see my QD, according to what we've done so far, my QD is 180 minus 3P. Let me slide that down a little bit. And my QS I know is 9P. So I just put in those two equations. QD is 180 minus 3P. I don't know if I need to spread this out. I don't want to confuse people. Oh, that looks ugly, sorry. So here's my demand equation. Here's my supply equation. Now the question is, can I solve this for P? Well, I can collect all my P's to one side, all my numbers to the other side, and we should be able to solve this. The hardest part is setting it up. All right, so since I like my prices to be positive, why do I take that negative 3P, I move it to close to the 9P, the other side the equal sign, and that becomes positive. So I end up at 180 equals 9P plus 3P. It looks like 12P. So 180 equals 12P. And P, therefore, is 180 divided by 12. And someone with a machine can confirm that that works out to P star is $15. So now we've found that our P star is exactly equal to $15, our equilibrium price. At a price of $15, quantity demanded of yams or sweet potatoes will be exactly equal to the quantity supplied of yams and sweet potatoes. At a price of $15, everybody who wants yams and sweet potatoes and is willing to pay $15 for a 25-pound bag can get as many 25-pound sacks as they want if they're willing to pay $15. And growers or farmers can sell as many 25-pound bags as they wish, as long as they're willing to charge $15. At $15, quantity demanded is exactly equal to quantity supplied. Our next job then is now find out, well, how many sacks would actually be sold at a price of $15? How many sacks will actually be demanded and how many sacks will actually be supplied? See, it's one thing to say, okay, at a price of $15, everybody can be satisfied. But we still like to know how much will actually be sold at that price. So to do this, we have to go to step 2. And step 2 and step 3, sorry, we plug our P star into our demand equation, and we plug our P star into our supply equation. Plugging a P star into our demand equation is 180 minus 3P. We plug in our P star, which is 15. So we end up with quantity demanded equals 180 minus 3 times 15. 3/15 is 45. So QD equals 180 minus 45. And 180 minus 45 is 135 sacks. So at $15, people are going to want to buy 135 sacks. What about us growers? How many sacks are we willing to put out there if we can only charge $15 a sack? So we plug that into our supply equation, and our supply equation is QS equals 9P. So when we plug in our P star, which is 15, we know QS equals 9 times 15, and lo and behold, it turns out to be 135 sacks. So we're willing to supply 135 sacks. Customers want to buy 135 sacks. Everybody happy. Therefore, and this is the way you would formally answer this question, this last line has to be included. Therefore, P star, which is our equilibrium quantity price, is $15, and QD, the quantity demanded, is equal to quantity supplied, QS, which is equal to our equilibrium quantity, Q star, which equals 135 sacks. I have to emphasize to you the formal answer to G in essence, everything else you did before is workings. When it comes to question G, your formal answer is this thing. P star equals 15, QD equals QS equals Q star equals 135. So you will get a, maybe 2/3 of your mark for all that working, but if you don't put in your answer, you can't get full points. And I know you're coming to me and saying, oh, see, Mr. Matt, see right there where I said QD equals 135? I said, yeah, but you want to answer the question. Okay. Any questions before we move on? So let's bring up your handout, your problem handout that I would have emailed to you. It's, let's see if I can find it. Yes, I'm hoping you can see this. It says Introduction to Macroeconomics, Summer 2021, handout number 4. Now, anyone can jump in at any time and help me walk through this. I'll let you in on a clue. Easier questions are first. But okay, that's entirely up to you. Okay. We have a demand equation, QD equals 40 minus 5P, and a supply equation, QS equals 15P. Right, we skipped all the preamble, but we have our equations, and we're asked the following 6 questions. At what price does demand fall to 0? If price was not an issue, how many cases of meat, obviously we're talking about meat, would consumers want? At a price of $2.50 per case, how many cases would then be demanded by consumers? What's the maximum price to the nearest dollar that can be charged and still sell? I'm gonna add up to the word. At least 11 cases. What is the maximum number of whole cases that can be sold? Well, that's an interesting question. We haven't seen it quite like that. And given a market price of $4, how many cases will Limber? Who's Limber? Oh, okay, this is the Long Island Mutton and Beef Association. Sorry. Be willing to supply. Okay. Any volunteers?
I'll go.
You want to go to the first one, don't you? It's...
Okay, I can do the last one if you want me to.
I know, you volunteer, you got the first one. Somebody should speak up faster.
Okay, well, I'll give somebody else a chance.
Mr. Curry, speak.
8.
Okay, so what do we do?
First, you assume that the quantity demanded is 0.
All right, so.
I'm sorry. Yeah.
Shall I assume that we made our box?
Oh, I'm sorry. Okay, we can make a box.
When you got your homework, you could do your box, but we can assume that we know enough that we can. No, you know what? Let me not do that.
Yeah, we'll make the box. We'll go step by step.
Yes, I need a box. Insert text box. Do you? And oopsie. All right, there we go. And now we need this, and this is QD equals, and this is P equals, and close it up. All right, and let's go with, yes. Okay, here's my box.
Okay, seeing what the question asks, it says, at what price does demand fall to 0? So we automatically get the value of QD, which is 0. We're trying to find the price.
Okay, all right, fine.
So we're using QD equals.
Which equation are we using?
Quantity demanded equals 40 minus 5P.
And we're using this equation because we look at this and we don't see anything that says price. I mean, anything that says supply.
That's correct.
All right. Okay. I'm good.
So it's time that we put in our values that we know, which is quality demanded.
Right. And we know that is
0.
0. Plug in what we know and solve for what we don't know.
That's correct.
Uh-huh.
So we've never seen a negative price before. So we move 5 up, the negative 5p over, and we move the 0 over in its place. So it's 40 minus 0. From there, we solve for p, which is 5p divided by 5. I mean, yeah, no, 40. You have 50.
5p divided by 5
equals 40 over 5.
Oops, wait. That's be 40, right? Okay, 40 divided by 5. Therefore,
so p would be determined to be 8.
Right. And I need to delete. Okay. Who's up next? Come on, people. This is easy.
Okay.
Hey, get to the good stuff here. Okay, you're gonna have to tell me who you are because I can't see the names from here.
No problem. Christina Curry.
All right. Yes, Miss Curry. If price was not an issue, how many cases of meat would consumers want?
Okay, so in the box, the equation.
What are you being asked for?
We're being asked for how many cases quantity demanded.
Oh, okay, so we put a question mark next to that.
Yes, and P would be equal to 0, considering the price is not a factor.
Okay, all right. And as usual, there's nothing in this question that says anything about supply, right?
No.
So then we know we're using...
QD is equal to 40 minus 5P.
QD equals 40 minus 5P. All right. Mm-hmm. And we plug in what we know?
Yeah, so we don't know which quantity demanded is. So we put QD is equal to 40 minus 5, and we know that P is 0. So we insert 0 in brackets.
Mm-hmm.
Okay, now QD is equal to 40 minus 0. So anything multiplied by 0 is 0.
I like where you're going.
QD is then equal to 40. And so, not an issue, consumers would want 40 cases of meat.
Yep. Good. I like that you put your units in there, finish it off, make sure we're right. We deal with cases of meat. Good. All right. So next. I need my box while people build up the courage.
I'll go. This is Bernique.
Miss Bain.
I'll make an attempt.
Okay, I have my box. What are we being asked for?
Quantity demanded, because we're given a price of $2.50.
So quantity demanded, I put my question, and you said the price is $2.50?
Yes.
$2.50. Anywhere in that question is the word supply?
No.
Okay, so we know which equation we're using.
Yes, so we're going to use QD equals 40 minus 5P.
Yeah, always put it down so we don't lose track of it.
Then you do QD.
Plug in what we know and solve for what we don't know.
Right, so QD equals 40 minus 5. And then put $2.50 in brackets.
Good woman. Okay.
Okay, so QD minus 40, take away 1250.
Oh, 5 times 250 is 1250?
Let me That's correct. Yes, yes, yes.
Okay,
that's right, 1250.
Okay.
So QD minus 40, sorry, QD equals 40 minus 1250 is 2750.
So if you would notice, no, you're right, it's finished. I changed it to 25 and a half because we're dealing with quantity.
Okay.
I mean, there's nothing wrong with the 250 keeping it 0, but when you're dealing with a quantity, it becomes superfluous. But that's fine. That makes no difference to our question one way or the other. All right. So at a price of $2.50, people are going to want to buy 25 and a half cases of this meat. All right. Fine.
I'm sorry, where did the 25 and a half come from?
Yeah, that lost me too.
27 and a half, right?
It should be 27 and a half. Where did the 25 and a half come from?
Is that me or that's Miss Bain?
I don't know. No, I said 27.50. Oh, okay.
So that's me. Okay. No, I wasn't testing you. Nothing. I just, that was me. My bad. Sorry.
Sneaky.
Yes.
No. Honestly, I can test you, but I can test you like that.
Wow.
I become more imaginative than that.
Why, Mr. Demerit, you trying to make sure we don't get them extra points, man? Don't do that, please, man. Please.
All right.
Extra points? What's that?
Yeah, man. The 25.5, we didn't agree. We start doubting ourselves at first.
I thought I was wrong as well.
Right. See, this is what I don't want you to do. And this is why we've spent so much time talking about the process, the methodology. Right? So when you said, you know what? I know I did it right. I know I took this step, this step, this step, this step, and that step. If that's the case, whatever the answer come out to be, that's what it is. Right? That's where you get to the point where you don't need to worry about, to doubt yourself, because you said, I know I follow the step-by-step process that I'm supposed to. It's only when I'm trying to sort of keep all this in my head and try to jump straight to the answer that you don't know whether the answer you got to is actually right or not. And you have no way of going back and checking. Sorry?
I could ask this follow-up question, right?
No.
You mean number 4?
No,
I mean that on Curry.
No, you could take it on. I was asking something as far as getting the answer, right? Yes. Okay, so let's just say we got the question wrong, right? But we had to use that value in another question. We used it the right way. Do we still get points for that follow-up question, or once we have one part wrong, the entire part is wrong?
This does come up. Not at this point in the semester, but in a couple of weeks, this question will become quite relevant, where the answer to one question helps you to answer follow-up questions. In that case, if you get the first one wrong, it's wrong. But I would then say, okay, if they use that right answer and followed the correct procedure every other step along the way, and they got everything else correct using that wrong answer, yes, you'll get the point.
Okay. Go ahead, my guy. Take number 4.
Mr. Mins.
Yeah, that's okay. All right, we can start off with our what we know. QD
in the box.
Yeah.
What are you being asked for?
We are being asked for, there's to $1 and what is maximum price.
We're being asked for a price.
Mm-hmm.
All right, so I put my question mark. Then there's a quantity in there somewhere.
It's 11 cases, sir.
11 cases. All right. Do I see the word supply anywhere in this question?
No, sir.
So we're not doing with the supply function?
No, sir.
All right.
So
Shoot.
we'll start off at QD equals 40 minus 5P.
Minus 5P.
Yes, that's
5P.
59. Okay. When we go down for quantity, we need to invert that. We'll be given quantity,
So
and that's 11. 40 minus 5P. Now, what we're gonna do is that negative price, so we're gonna bump that over to the QD side. 5P equals 40 minus 11.
So you move the 11 over.
Move the 11 over.
All right.
Now what we have is we're gonna take 5P, use that next 5, divide that by, and slash and kill that.
Whoa. You don't do 40 minus 11 yet. What I get for that?
40 minus 11, I give you 29.
All right, okay.
Sorry, my bad.
Okay. So, and you said you do your 5P divided by 5?
5, yes, sir.
And that gives me, what I do on one side, I have to do on the other side?
Yes, sir.
All right, so then I have 5P divided by 5 is just P equals, what's 29 divided by 5?
That's 5.8, sir. Or $5.80.
$5.80? $5.80.
Yes, yeah.
All right, so then, what's the two possibilities? It's set to the nearest dollar.
Looking at $6,
$5.
$5 and $6. If you're gonna use those. Okay, P equals $5 or $6.
All right, those are two possibilities: $5 and $6. And what did we say?
Okay, we're gonna go with QD again. Minus.
Talk to me. The question is, you want to work out each one individually? You want to test each one, or you know which one it's supposed to be?
No, we're gonna test it. We're gonna test it because.
Sure, you like working hard, but
I mean, we can roll with the $5 because if we go less than $5, we know that it's gonna work in our favor because we're not going above 580. You go above 580, you're pretty much just screwing yourself over. But if we go to $5, we could look at that and just put $5.
But that $6 look close, you know.
It looks close, but it's still gonna it's still over our price, which is our price is 580 when we worked out. And we
can't go over $5.80.
We don't want to practice that. No, we don't want to do that. We want to come out on top. We don't want to lose. So let's
at $5.80, we sell 11 cases. If we go to $6, do we sell more or less than 11 cases?
I gotta work that out, man.
No. You're not gonna work out. If you increase the price, you sell less.
Sell less.
Sell 10.
It don't matter how much it is. It can be less than 11. And we know we can't go less than 11. We have to sell, according to the question, at least 11. Charging $6 ain't gonna let us sell 11 because that's more. $5.80, we sell 11.
To 15.
$5.85, we sell less than 11. $5.90, we sell less than 11. $5.81, we sell less than 11. Anything above $5.80, we sell less than 11. And we can't sell less than 11. Now, Mr. Mintz, we can happily test both. Yeah. Okay, not happily. Yeah, I'll grumble about it, but I'll do it for you.
I mean, I could practice it. I could practice it at home because I already know from what you said. You gotta stay beneath. You gotta stay beneath. If that's what your goal is in this particular case.
No. We can do the right thing. We can do Spike Lee. All right, we can test both. All right. So to test both, we plug the $5 back into our demand equation. We also plug $6 back into our demand equation and see how much is sold at those prices. Right. So here's our first demand equation, QD equals 40 minus 5P. And let's put the next one over here. QD equals 40 minus 5P. All right. So tab. Oops, I'm missing a D, aren't I?
Yes, sir.
So QD, I'm listening.
Equals 40 minus 5P. Fine, 5, then we can put our $5.
See, we're doing both at the same time, so you have to think fast.
All right, 40 minus 5. Put our 6 in there. 6. Put our 6 in there. Then we go.
Oops.
We 5 times. Okay.
Equals 40 minus 5 5s.
25.
25.
Right. And QD equals
30.
40 minus 5 6s.
30.
30. All right. Tab. QD equals 40 minus 25.
15.
Tab. And QD equals 40 minus 30.
10.
So,
Too much.
at a price of $5, we sell 15. At a price of $6, we sell 10. We need to sell at least 11. So this ain't gonna work. Because this only allows us to sell 10 and we need to sell at least 11. $6 ain't gonna do it. So we have to go with the $5.
Right. So question.
Yes.
When we've arrived to the consensus saying we have to sell at $5, we'll write a notation somewhere saying we select $5, which will give us 15 cases unless more than 11.
Therefore,
right. Okay, that's what I'm saying.
We would, because what the question is, what's the maximum price that can be charged? Right?
Still
we
sell
would charge 5.00. That's it.
Okay.
Or if you want to put per case of meat, that'll be fine. Or whatever the unit is that we're talking about.
Okay.
See, you're answering the question. So
right.
The question is actually in words, you can answer in word. What's the maximum price that can be charged? Therefore, we would charge $5 per case of meat.
Okay.
So, Ms. Thompson, now that we're chatting.
No, I was giving other people a chance to talk this week.
Get them.
Okay. Copy to put my box down. Because what do we always say? Stop my box.
The whole cases that can be sold below.
Okay. So now we have to see if we can interpret what these people are trying to say in a way that we know how to address it. See, once we can put it in a form that we're familiar with, we know how to deal with it. Okay. So the question is, what is the maximum number of whole cases that can be sold? Assume that the price cannot fall below 150. First of all, Ms. Thompson, do we see the word supply in there anywhere?
Supply is not that the word supply.
Well, so we won't assume supply is in there anywhere. We wouldn't presume, we wouldn't try and interpret this to say supply. We're saying the word supply ain't in there, so we must be talking demand.
Right.
Okay, fine. But think about this. All right. So I gave you the shortcut. If the word supply ain't in there, we ain't talking about supply. But in terms of understanding the question,
right, I know it was tricky.
The question is saying, what is the maximum number of whole cases that can be sold? You cannot sell something that people are not interested in demanding. Too often, students want to interpret can be sold to mean what people put on the shelf. That is not the same. There is available to sell, that's supply. But the question is, what price you need to charge to make sure people want to buy whatever number of cases that he wants to offer. All we're saying is that the easiest way to look at this, the shortcut, is that you're looking for the word supply. If it ain't there, you're probably dealing with demand. But when it comes to a question that says, what's the maximum number of whole cases that can be sold? You can't sell something that people don't want to buy. Right. You can put it on the shelf, but if nobody's going to buy it, it will never be sold. Right. So that being said, can we answer this? I made you start thinking too deep.
Based on what you are saying, it seems as if people don't want to buy that. So we won't be able to sell it.
No. Okay, let's rephrase the question. What is the maximum number of whole cases that people will be willing to buy, assuming that you're not willing to charge less than $1.50? Does that sound like demand?
Mr. Demerit, you have me confuddled.
Okay, then don't think about it. The word supply ain't in there, we're dealing with demand.
Okay.
Okay. That being the case, what are we being asked for?
The quantity demanded.
Okay. And quantity, question mark. So the price must be in there somewhere.
$1.50.
All right. Price of $1.50. All right. Fine.
So
plug in what we, okay. I'm listening.
QD equals to, what is it, 40 minus 5P? So.
All right, so we put down our equation first, so we know what we're working with, plug in what we know, and solve for what we don't know.
Right, so QD equals to 40 minus 5 in brackets $1.50. So QD equals to 40 minus, give me a minute, $1.50 times 5, $7.50. QD is equals to 32.50.
32 and a half cases. All right, fine.
Why that sound so?
Why that sound so
hard?
What do you mean it sounds so hard?
The question. Oh, I was listening to that wrong. Maybe only me. I don't know.
It sounds harder than what it was.
Yeah, oh, I'm not the way I used to seeing it. Let me put it like that.
But is the question finished?
That can be sold. That's what we're looking for now.
No. Read the question again.
What is the maximum number of whole cases that can be sold?
And what is your answer?
The maximum number is 3250 cases.
32 and a half cases.
Sorry, 32 and a half. Bye-bye.
And what's the question asking you for?
The maximum number of whole cases that can be sold.
Stop. Maximum number of
whole cases.
Whole cases. And what is your answer?
32 and a half.
You don't see something wrong there.
So they need half a case then 32 divided by 2. 3250 divided by 2 is a whole case. I don't know, Mr. Demerit, you're trying to confuse me.
No, I'm not trying to confuse. I'm asking you a question. They're saying
somebody else chime in because I feel all lost.
No, Miss. You know this. They're saying, what is the maximum number of whole cases? They're saying your answer has to be in whole cases.
Okay, so now we have to figure out either.
All right.
If it is 33 or 31 or 32, my bad.
Exactly. No, and you're bad. You got it. We need to figure out, we need to find whole cases.
Oh my God.
we have a half case, 32 and a half case. He don't want to sell half cases. All right. He don't want to cut his slab of meat in half. All right. I sell a whole package. I don't want to sell half package. Right. So what right now, if I were to charge $1.50, I end up with a half of a case at the end. Right. So the question is, all right, he needs to charge a price that's going to let him sell the most whole cases that he can sell. What is the maximum number of whole cases that I can sell, assuming that I refuse to drop my price below $1.50? So you're following his logic?
Yes, sir.
Okay, fine. So our job then is, okay, we're following his logic. How do we satisfy the conditions he's putting out there? So his two conditions he's established. He said, one, I don't sell half case. Don't come looking for me for half a package. I sell my meat in whole packages. That's his first condition. His second condition is, I ain't dropping my price lower than $1.50. So then, we know that the two closest whole packages is either 32 or 33. You'd agree with me?
Yes.
Okay. So then, would it be completely crazy to test both 32 and 33 the way we did previously when we tested $5 and $6?
I would think that's the way to test it.
But now, where previously we were testing prices, now we're testing quantities. Right?
Right.
Okay, so why don't we do that then? Why don't we say, we know that one possible QD is equal to 32, right?
Mm-hmm.
Or would you agree with me? QD is either 32 or 33.
Right.
So what did we do when we were testing the prices? How do we test? How do we check them out to find out which was the right one?
We added the 32 to the equation. QD equals to what?
So I see. So we plugged the two different prices into the equations.
Right.
Why don't we do the same thing, except plugging in the two different quantities?
Right. 32 and 33.
All right, fine. So here's my first equation. QD
equals to 40 minus
5p. Because we always put on the equation first.
Mm-hmm. And then QD.
Let me move it over so it lines up with the proof. All right. And QD equals 40 minus 5p. All right. So those are the two equations. Now we're going to plug in our two different quantities.
Okay. QD.
Oops. You know what? Let me go on to a new page. I hope you guys keeping track so I don't get lost. All right. Yes, Ms. Thompson.
Equals 40 minus 32.
No. What are we testing?
The 32 and the 33, the cases.
So wouldn't we put the 32 here because that's quantity?
Oh, the quantity demanded. Yes, you're right. Equals to 40 minus the 5p. Okay. And then
we do the same for this one?
33 equals to 40 minus the 5p. So 5p now will be 32 equals to 40 minus 32. And then 5p.
Okay, now you're going to fast for me. Okay. So now you hit your stride. Now you're a little bit more comfortable. You know where you're going.
Right. 40 equals.
Mr. Lemire, no, I don't know. Ask somebody else.
Yeah, because 33.
No. Okay. 33. Okay.
And so we'll cancel out the 5. So it'll be P equals.
Wait, you're skipping a step.
Sorry. Okay. Yeah, I was. 5 divided by 5. And then.
No. What's 40 minus
32?
32?
8. My bad.
Mm-hmm.
And then 7.
5p is equal to 7. All right. So then P, or I could do 5p divided by 5.
Right.
Equals 8 divided by 5.
Right.
And 5p divided by 5 equals, oops, what did I do? Equals 7 divided by 5, because whatever I do on one side, I have to do on the other side.
Right.
So I end up with P is equal, what's 8 divided by 5?
1.6. Or
$1.60, because we're dealing in price.
Right.
It gives me P is equal to, what's 7 divided by 5?
$1.14.
What's after the 4?
40.
1.42.
Oh, $1.42.
Is 1.428.
$1.43.
1.1428.
Okay, 1.1428. So $1 and 1.114, because there's a 2 after the 4.
Right, 14 cents.
Okay. $1.14.
No, it's supposed to be sorry, I didn't mean to intervene. It's supposed to be $1.40.
$1.14.
40.
I thought it's 1.14. 1.114?
1.40.
Oh, $1.40. 40 is correct.
$1.40.
My bad. Sorry.
$1.40.
Yeah.
Okay, so here's your 2 answers. Which one is correct? What does the question say?
They want to know what's the whole case that they could charge without falling below $1.50.
Right. So there's 2 parts of it. We worked out the whole case. It's either 32 or 33, and the price cannot fall below $1.50.
Therefore, we'll have to charge $1.60 and sell at 32 cases.
Bingo. All right. So then, let's see. Actually, therefore, we will charge how much? $1.60 and sell 32
cases. Can I ask a question?
No,
please,
you can't.
Please.
Of course you can ask a question.
Okay, so was it only me, just for the class, was I the only one reading that wrong, or everybody?
It took a while for me to see it, because you're thinking about the previous one, which was dealing with more or less with the dollar money, and this one was dealing basically with the quantity.
Because I felt so dumb up in that just now. I was like, what? But as I saw
it was something brand new.
Yeah, that's it. Something brand new.
But you realize very quickly, once you're able to bring it to something that you were familiar with, then you fell back into the rhythm of how you go about solving these. Yeah. So you can find the hardest part of these, and a lot of things in this class, the hardest part of this is going to be sort of, not the math itself. The math is relatively straightforward. All right. It's just setting it up into a familiar form that you can wrap your hands around. Right? These 2 questions, 4 and 5, one is asking you to find a price, and one is asking you to find a quantity. And they're establishing certain conditions associated with that. So number 4 asks you to find a maximum price. Number 5 is asking you to find a maximum number of whole cases. So again, your approach is really the same. You have an absolute answer that you've come up with. Right? But you know that answer can't be the final answer because of the conditions that's been established. So that you said, okay, there are 2 possibilities. Right? When it comes to price, we've already said We can even dispense with the test and we know we can't go up. Look at the quantity. Can we figure a similar simple rule for quantity? It was 32.5 cases. Could we go up to 33?
No, because then we'll have to sell at $1.40.
Right. We would have to sell less than $1.50.
Right.
So similarly, we can't go up with this either. So whether we're talking about price or the quantity, here's it. We know the law of demand says that price and quantity go in opposite directions. And when you were faced with these two types of questions, and you will get both of these, both in your homework and in your exam, and we have a midterm coming up in what, 2 weeks?
Yeah.
Yeah, well, it's only what, 7
2
weeks?
Come on.
And then
Already?
you got some stupid holiday in the middle there somewhere. And they tell me I
Hey,
have to
stupid
take, so I
holiday.
take off.
Week after
Holiday
next,
is
I believe.
Monday. So do we have class on Monday?
Is it this Monday?
Yeah,
It
Monday
is the
come in.
24th.
Oh, it's next Monday.
Next week.
Monday
Monday.
coming next week, Monday?
It's this Monday coming. No, I thought it was some following.
Today is Wednesday, so it is Monday coming.
Monday
Monday
coming.
coming, the 24th
Yeah.
of May is with Monday.
Monday
Yeah.
coming.
I wasn't planning on giving y'all a homework today, you know.
Man, just slap us with it one time.
No, the idea was because there was stuff I wanted to make sure we covered. This was one example before you are faced with homework, and we haven't even begun looking at scenarios as yet. So I'll have to wait till next week. Anyway, fine, whatever. Can we finish this off, and please?
Yes, please.
All right, so you can't go up. Whether you're talking price or quantity, the way these questions are going to be set up, you can't go up. Your price can't go above your absolute price if you calculated. Your quantity can't go above the absolute quantity that you calculated. I won't get so fancy, so technical, so diabolical that I'm going to mess with that. All right. Maybe if you were doing, intermediate macroeconomics, then we'll have a lot of fun. But unless I really want to do intermediate macroeconomics, it's really fun.
That's cool. You can run that by us.
Anyway, fine. Anyone want to do question 6? It's almost a giveaway.
It is.
All right. Fine. What's the first thing you know about question 6?
Supply.
Thank you very much. So we know we're doing the supply equation. So QD, no, not QD, QS is equal to what?
15 P.
15P.
All right, fine. They're asking us for quantity supply given the market price because they tell us the price.
15, open bracket 4. 15, open bracket 4. QS equals 60.
That's it. Okay. So, since I'm not giving you any homework, can we practice these last 5 questions over the weekend?
Yes.
No grade or nothing, but to allow us to run through them fairly quickly come next Wednesday.
Yes, sir.
All right, fine. Let me save this.
Are you going to email this up, please?
I did promise you something before. Hey. All right, I guess I could do that.
Please, thank you.
Oops. Okay, so then you should also have moving along the curves versus shifting the curves. Handout number, I don't know what the number is.
3. Number 3.
So you need
Yes, sir.
handout number 3 and you need handout number 2. Let me pull up both of them. All right. Handout number 2 is market equilibrium graphs. All right. So let's start with the graphs. You have 9 possibilities, A through I. And if you notice, our graphs are properly labeled. All right? There's a demand. Each of these have demand curves and a supply curve. The first graph says that neither demand or the supply curve shifting. And this is an illustration where there's a change in a price and you end up moving along the curves, but you don't see the curves actually shifting. Graph number 2, you see the demand curve doesn't change, but quantity supply curve shifts, see the arrows, in and to the left. That means supply fell. And it says quantity supply falls, but quantity demand, there's no change. Then C, the supply curve shifts out and to the right. Quantity supply rises, but quantity demand doesn't change. D says, okay, but now the quantity supply doesn't change, but quantity demanded shifted out. E, supply didn't change, but quantity demanded shifted in. F, both quantity demanded and quantity supply increased or shift out. G, both quantity demanded and quantity supply shifted in. H, quantity demanded shifted in, but quantity supply shifted out. And I, quantity demanded shifted out, but quantity supply shifted in. So the challenge that we have is that we are going to be given a number of real world scenarios, right? And we have to try and match up what we think is happening in a real world scenario with what we see happening with the demand and supply of this good or service. So we're looking at the market for an individual product and see if we can match that up to one of these graphs. I will help you with the first couple, and then we'll pick it up one by one and see if we could talk our way through each of these. Now, let me bring it up again. Okay, so it's kind of, okay. What are you seeing on your screen now? Are you seeing the graphs?
No, that's
No.
the questions.
Were you seeing the graphs previously? Okay, so let's walk them one at a time. All right, let's talk our way through these. The question says, for the following scenarios, identify the graph that best illustrates the market for the product that we have in bold. So what we're asking ourselves is that given these scenarios, is the demand for this product going to go up? Demand for this product going to go down? Sorry, let me try this out again. Based on this scenario, do we see the demand curve for this product shifting out? Demand curve for this product shifting in? The supply curve for this product shifting out? Supply curve for this product shifting in? Or only thing the scenario is telling us about is movements along the curve? So if you have your notes handy, we're looking at the factors that affect demand and factors that affect supply. So let's start it off slow. And once we get the hang of it, it will go a lot quicker. Well, maybe not quicker, but a lot, okay, not even easier, but we'll see. Ministry of Health launches an intensive media campaign to reduce significantly car accidents due to alcohol consumption. Okay. If we look at our notes for factors that affect demand and factors that affect supply, does any of this sound familiar?
Yes.
Okay. Which factor would you associate this with?
Reducing consumption, alcohol consumption.
Yeah, but no. Let's look at the factors we have. Let's see if I can pull it up. Yes. Okay. Can you see my Excel spread? My PowerPoint presentation.
No, sir.
No, sir.
Okay, so let me stop that. Oops, screen share. Okay, you should see it now. Yes?
Yes, sir.
No?
Would we look at the graph, right?
No. We're looking at
my
factors.
class notes, my PowerPoint
Okay,
presentation.
yes, sorry.
So we're looking at factors that affect demand.
Oh, pricing.
We said the price of a good, income,
okay,
whether the good is a substitute or a complement, population, taste and preferences driven by advertising, expectation of future prices. Right? If you have your class notes open in front of you, I would want you to keep that available to double check. All right. And if we go back to our scenarios, which you should be able to see now.
Mm-hmm.
All right. If the Ministry of Health is launching an intensive media campaign.
Oh, the price.
Does that not sound like advertising?
Yes.
Yes.
We're trying to change people's preferences.
Mm-hmm.
Y'all like to drink and drive. We're trying to get y'all to stop doing that foolishness.
Especially in Hondas.
All right. So the Ministry of Health has launched an intensive media campaign to reduce significantly car accidents due to alcohol consumption. That sounds, in my head, and see if it sounds in yours, like taste and preferences driven by advertising.
Right.
This one here.
Mm-hmm.
All right. So then, what impact is that likely to have on the demand for alcohol beverages?
Negative.
None.
You're a dark.
I swear. I swear.
We would hope that through this campaign, we're able to slow down drinking and driving.
The price definitely would affect it now.
But she has a point though. Like, I mean, even through the pandemic, people like through the
That's the only thing
inflation
was selling.
prices, through the inflation of prices, people were still buying it regardless of how much money they had. Like Hennessy bottles went from $45 to like $70, $80, $90. People still wanted to buy it. So,
but
I mean,
we're talking about drinking and driving, and we have splashed this all over radio, TV, newspaper, Facebook, Twitter, massive media campaign, raising awareness about drinking and driving, and you don't think it's going to have an effect?
None.
Oh, of course. I mean, by the book, yes. But in the Bahamas, no.
None.
Because people still drink and drive now, even though like they're heavy on that now.
Yeah,
like,
but
it hasn't really changed, even when it comes to seatbelt laws and stuff. That hasn't changed anything.
There will be a marginal, even if you say it's a marginal, all right, there will be a marginal change. All right. I think it'll be more significant than that, but okay, we can argue about the degree. But certainly you would expect there to be an increased awareness of the dangers of drinking and driving. Yeah, and you may increase the times when parents chastise their child who, their adult child who's going out for the evening, reminding them, somebody who just get killed, wrap themselves around a tree for drinking. We saw this on the news, we see in the newspaper. There's going to be some decline. Right? You say this is the Bahamas, or maybe not as much as in some countries. We can argue one way or the other, but likely there's going to be some kind of decline.
Okay.
Here's the question. If there is going to be some decline, is that going to affect all brands of alcohol? Some degree,
Yes.
not brands, sorry, all prices of alcohol, whether you're talking cheap Radbat, medium price stuff, or even high-end stuff.
Yes.
Okay.
Yeah.
So then, let's go back to our curves then. You should be able to see the curves now.
Yes, sir.
Yes, sir.
All right. I'm going to move this out of the way because I don't know why I keep hitting it away. So then, we think that's going to affect demand. Would you agree?
Yes, sir.
It should, even if it's tiny, tiny bit, slow down the demand for alcohol at all price levels. We would see that as a shift in the demand curve for alcohol. A reduction or a leftward shift in the demand curve for alcohol. Any objections?
None.
So first things first, then we will be looking at a graph that shows a leftward shift in the demand curve.
E.
All right. So far we know E would show a leftward shift in the demand curve. All right. But so would G. Yes?
Yeah, but isn't G
I agree with
also,
G.
but isn't
I would
G,
think it's G.
G is
No,
also reflecting supply.
we ain't finished yet. Because remember that we only read half
Because
the
of the
question.
tax.
We only read half the scenario. All right. Let me bring it up again. Here's the scenario. All we've done so far, we said, Ministry of Health launched the campaign. We think it's going to have some effect. That's the first half. And we think that's going to cause demand to fall. What about the rest? At the same time, they quadrupled the tax on all types of production and or distribution of alcohol beverages.
Duly noted.
This is gonna rise.
That's G.
Oh, y'all think y'all slick. I know my people. So I not only I run this campaign, I can tax the hell out of y'all. I ain't even tax y'all. I can tax it at the source. I can tax Bahamas Brewery. I can tax what people by St. Francis Church. Right. I can tax all y'all trying to bring in alcohol.
Mrs. Demerit, thank God you're in the Prime Minister.
I got all kind of thoughts.
He quadruple it though.
Yes. Quadruple, not even double. Not even double, quadruple.
Y'all take bad. Yeah. So then, we know the first half of this, the media campaign will have an effect on demand. What about this second half?
Price is gonna rise.
No, it's gonna fall. Because you're gonna
get less. You're gonna buy less.
We ain't seen nothing in there to say about the price yet.
No. Well, if
right now, we taxing Commonwealth Brewery, we taxing Watlands, we taxing the distributors, we taxing the importers.
Well, Watland's gonna charge us. They're gonna put that price on us.
Price goes up, demand goes down.
Maybe.
Right. They no, they
they're not gonna produce as much anymore.
Because if supply goes, but if demand goes down, the price goes down.
So let me ask you this. All right. I am whomever it is, and I'm bringing in liquor. Right. Now, I know government running this major campaign trying to stop you off from drinking and driving. And then on top of that, they pile in taxes on top of me. I can bring in the same amount of liquor?
Mm-mm.
Nope.
Nope.
Definitely not.
I can brew the same amount of Colette?
Mm-mm.
No, less.
I can brew the same amount of Sands?
Mm-mm.
See,
Nope.
I could see what's going on. Government running this campaign, and they killing me with the tax. In fact, let's go back to our factors that affect supply. Let me scroll down. And we said one of the factors that affect supply is subsidies and taxes. A tax is a sum of money demanded by government. An increase in taxes leads to a decrease in supply. That's why I'm asking you to keep this handy, because this is going to guide you in terms of trying to have a supportive argument for the choices that you're going to make in your answer.
Okay.
Because you can't tell me that supply ain't a change when I could go back to the notes and we can see that we agree when they increase the taxes, supply is going to go down. So let's go back. I need you. Right. Two things now we know. We know demand is going to fall, right? Because of the advertising campaign. But we also know supply is going to fall because of the tax situation. So we're looking for a graph that have both demand falling and supply falling.
Gee.
Anyone have another option? I would go with G2.
No, I agree with G.
Both quantity demand falls and quantity supply falls.
Right. Yeah, go G.
Now, it is true that what we call the second step in this process, or the second order condition, as these firms are also going to increase their price. But the first things first is that they need to realize that I can't afford to bring in the same amount I was bringing in before. Not with the kind of taxes they charging me on every item I bring in. Have a next one? Of course you do. You like working on your brains. All right, here's another one. Abaco citrus farmers. Right? This is orange, tangerine, and grapefruit. Right? Have found. Is somebody doing their nails? Ms. Thompson.
No, it wasn't me, sir. No, sir. I don't know, sir. I'm listening to you. It wasn't me.
Yeah, I know, but I like calling your name.
Oh, that's good.
Okay. Abaco citrus farmers have found that they can source more cheaper fertilizer from local chicken farms. So they're using chicken manure. So Abaco citrus farmers have found that they can source cheaper fertilizer from local chicken farms rather than importing it from abroad. Okay, let's pause there for a second. Is that likely to affect the demand for oranges? Let us go back.
Yes.
Well, we don't know yet. Let's go back. What we do is we go back to our variables that affect demand. Okay. Does it have anything to do with the price of oranges?
No.
All right.
No, but the price of the fertilizer, eh?
Yeah, but what does that do with the price of oranges?
No.
Does it have anything to do with income?
Yeah.
Really?
I don't know.
So they get cheaper fertilizer, but you get more money in your pocket? You get a raise? Them getting fertilizer, does that have anything to do with substitutes or complements for oranges?
No.
Does it have anything to do with the population of people who are consuming oranges?
No. No.
Does fertilizer have anything to do with our taste and preferences for oranges?
Nope.
Nope. Not unless you die.
Them getting cheaper fertilizer, does that say anything about the price changing down the road?
No.
No.
All we know is that they get cheaper fertilizer. So we, at this point, we don't expect that to have any effect on demand at all. His question though, does it have any effect on supply of oranges?
Yeah,
What's
I think.
what's the purpose of fertilizer?
Consistent growth.
To nourish the plant.
It should make the plants grow faster, produce more oranges?
Yeah.
Yeah.
So they should be able to supply more oranges then.
More oranges, yeah.
Because cheaper fertilizer means that their input in the production process, which is, is less costly. So they're able to do more fertilizing of their stuff so they can grow more oranges. So we would hope then that the supply will go up.
Would it affect their aspect in regards to supply of technology, saying that something, it gave them the ability to improve and reduce costs simultaneously?
Is fertilizer, well, if the question had framed the fertilizer, some new, improvement in fertilizer technology, sure, but that's not the case. All we're saying is, we switch from imported chicken manure to local chicken manure.
Okay.
Because local is cheaper. So we certainly can produce, it should assist us in producing more oranges because it helps our plants. Right? So then, first things first, we know supply is going to go up. So we're looking for a diagram that leads to a shift in the supply curve. C does it, supply goes out, right? F does it, supply goes out. See our QS curve.
H does it too.
H does it, supply goes out. Those are only three, right? All right,
yes, sir.
So let's look at the second half of our scenario then. So Abaco citrus farmers, you can see this, yes? Abaco citrus farmers have found that they can source much cheaper fertilizer from local chicken farmers rather than importing it from abroad. We think that's going to cause supply to go up. Unfortunately, consumers have been getting sick from a parasite that has made its way into the citrus fruit being produced and sold by these farms. Is that likely to affect demand or supply of citrus?
Demand.
So we think demand is going to go down. Really, it's negative advertising. Yeah, it's like you hear skunk poisoning, you can stay away from skunk. So we think supply is going to go up because of the cheaper fertilizer.
Yeah.
But demand is going to go down because of the parasites.
So Mr. Demerit, let me ask a question within the same type of scenario. Can you hear me?
Hang on, let's see if we can find which one first. We're looking for demand to fall and supply to go up.
WH.
H.
H.
That's correct. H.
Yeah. Okay. I could buy that. All right. So, question, Mr. Curry. Yes, Mr.
Oh, okay. So let's use something like conch. Like right now with conch.
What's happening right now with conch?
They're considered poison and they're telling nobody to eat it.
Okay.
Consume
Wow.
it. Right?
I haven't had conch in forever.
Boy, I don't think you want to have it now.
No.
But
I can lose some weight.
I don't.
Not that way.
Trust me. You
Not
don't
that
want
way.
to
Trust me.
You sound just like somebody I know who had dengue fever, who said that they want to have it again so they can lose weight. But anyway, that's besides the point.
Yes. Okay.
Like, okay, let's use it in this type of situation where not much people are fishing conch, but there may be those few who saying that, hey, well, they have the water to themselves because they didn't hear the news that conch is poisonous, right? Now, you're saying to me that they have an influx of conch coming in, but due to the news saying that they're poisonous, there's less people coming to buy it. Like, it would not be the same scenario, or like to put it in realistic terms, that due to the fact that the news told everybody that conch is poisonous, that the producers and the consumers go down.
Okay, so you certainly expect demand to go down because of the poisoning. Yes?
Yes.
Okay. So the question is, will supply go up?
Yes.
No,
why would supply go up?
No, I was asking, like, yes, that would be the question. But more than likely it would go down, considering that,
Yeah, because why, as a fisherman, why would you go out looking for conch knowing that you can't sell it when you come back? Wouldn't you go look for something else?
But let me put another spin to it. Yesterday, I already had 100 conch.
Right.
I know I can't sell it now. There are some of those who feel that they have an iron stomach. Yesterday I was able to sell 10. Now today I'm able to sell 5 out of the 100. I might be jumping the gun when it comes to this with the demand and supply. But does that mean the demand curve changes, or does it stay the same?
No.
The supply curve changes or stay the same in that case? Not demand. I know the demand goes down, but does the supply curve change or stays the same?
It has to. It would change.
Why would it change? I'm asking
because
genuinely.
The question is that why you are supplying less to the market, right? Aren't you?
Yes, I am. Yes.
Okay. Let me turn that scenario around. You are a conch fisherman. You already have stores of conch, right? Frozen. Right? Now you hear rumors. It ain't hit the news yet that people been getting sick from conch. What do you do now?
Check to see if that's true.
Oh boy, sale.
No, you know what I mean? Because people ain't worried whether it's true or not. Once that get out in social media, you know them conch will be sitting in your freezer forever.
That's true.
So what do you do now?
2 for 1 on the corner.
Yeah.
Exactly.
Tropical.
Cut your prices, and heighten your demands. Get everything going right away.
Yeah, but okay. Let's turn that into our economics. Are we talking? What are we talking about in terms of? Are we talking about a change in the demand for conch or change in the supply of conch? Now, listen what you just said to me. You said to me, because of the rumor, it ain't hit the general population yet. But as a conch fisherman, you catch this first. You know then that I need to get rid of the conch that I got stored. I can have 2 for 1 sale, whatever. Doesn't that mean you are increasing the supply of conch?
Yes.
You are pushing this to get it out now while the getting is good. So here, even though nothing has changed, in fact, certainly the price hasn't changed, but you expect there to be a change in the future. And that is affecting what you do today. Expectation of future prices. It doesn't matter. All of these scenarios, we can bring them all back to the factors that we've identified that are going to affect demand and supply. And that's going to tell us whether the curve is going to shift or not and which direction it's going to shift in. Can we do one more before we call it a night? Because I see I have 8:16.
Yes, sir.
Yeah, we could do another one. So which one did we said H, correct?
Yeah.
We said H.
H.
Okay, fine. Number 3. And let me bring it up again. All right. Price war breaks out between Cable Bahamas and BTC. And Bahamians are benefiting from drastically cheaper cable, cell phone, and internet services. Right. So, what does the market for consumer tech services look like given this price war that's going on?
More people getting cable because the price probably dropped.
Yes, absolutely. More people getting phone, more people getting cable, more people getting internet. Absolutely.
So demand getting up while prices going down. Supply going down. So.
The question says there's a price war. Prices of everything going down, right?
Yes.
What does that mean for our demand and our supply curves?
That
Going to
means
increase.
the demand curve will shift to the right because more people will get demanding these services. But for the suppliers, their curve will shift to the right, to the left. Because they'll be dropping the prices to be competitive with one another.
Okay. Now, let's listen to what we're saying. We're saying there is this drastic change in the price. But what do we know about changes in the price level? What does that do for our curves?
The price.
Let me bring it up.
Yeah.
Oops, wrong one. What effect does change in the price have on our curves?
Price goes down, demand goes up.
But what effect does it have on our curves?
It's the curve to the left, slightly inward.
Does it?
We'll push it out.
Put it up.
Remember what we said. A change in the price level moves us along the curves. A change in any of the other variables causes the curves to shift.
Yes, right.
So let's say we're at P1 and the price war causes the price to fall from P1 to P0. Demand, of course, goes up from Q1 to Q0, but in essence, we're moving along the curve. The curve doesn't shift when there's a change in the price. A change in the price moves us along the curves, either along the demand curve or along the supply curve. It's only a change in any of the other variables that causes the curve to shift. So yes, more people are going to demand more of these services, but they're only going to demand more of these services because the price changed. Everything else we've considered to this point affected all prices of this product. Right? Whether we're talking about the conch issue, whether we're talking about the oranges issue, whether we're talking about the liquor issue, right? We were talking about all prices of this product, whether we're talking cheap, middle price, or expensive price, all change. When we were taxing liquor, we weren't only taxing cheap beers, or homemade brew. We were taxing everything. So the demand for everything changed. The supply of everything changed. When we're having our advertising campaign, our advertising campaign wasn't just aimed at low price products. Our advertising campaign was aimed at everything. When we were talking about people getting sick from oranges, we weren't talking about people getting sick from oranges sold on the side of the road, or sick from oranges being sold in the supermarket, or sick from oranges that you go on the farm and pick yourself. All oranges. That's what we mean when we said the curve shifts. The curve shifts when we're talking about a change in demand for a product at all price levels, or a change in the supply of products at all price levels. If there's an improvement in technology that allows us to produce, let's say, a cheaper chip for our phones, that will apply to all price phones. That will make it more cheaper for us to produce and sell all phones, not just the most expensive phones. So that will cause the entire supply curve for phones to shift. But when we're talking about a change in the price level, right, that's going to move us along the demand curve. So we do want to be careful of that. We won't see it. Oops, what did I do? Because it's easy to get caught up in thinking about just shifting the curves one way or the other. Mm-hmm. In this case, this particular example, we are moving along the curve. Very last one then, number 4. I don't know if you can see this. Yes, you should be able to see this.
Excuse me, Mr. Mayor.
Yes.
Which one? Oh, we don't have that one here. Moving along the curve. I mean, one of the
number 3.
The graph.
Yeah. Oh, yes. Number 1. It's the only graph where the curves do not shift.
So A.
A. Okay. What about number 4 then? Poultry producers on Gladstone Road have found that the cost of chicken feed continues to go up month after month with no sign of stopping. With no other option, they are forced to pass on these increased prices to consumers. All right. Is chicken feed an input in their production process?
Yes.
So if their cost of input goes up,
the price of chicken goes up.
Chicken goes up too.
First things first, does it affect the amount of chicken that they can supply to the market?
Yes.
Yeah.
Up or down?
Down.
Down.
Okay. Why?
Because it's expensive to feed the chickens.
So they can't have as many chickens.
No.
Okay, fine. So supply goes down. What about demand?
The demand will go down also.
Really?
prices goes up.
Right. And what did we say about prices? What did we just say about prices?
Move along the line.
Move along the line.
Right. So yes, demand for chicken goes down, but it goes down because the price changed. So we would definitely see a shift in the supply of chicken, right? But we wouldn't be able to see a shift in the demand curve for chicken. All right. I think we're tired. So what we'll do, we will, we'll look at these again sometime between now and next. When we meet again, like 10 weeks
In
from
3
now.
weeks.
Okay.
Next Wednesday.
In 3 weeks. That's like around June
Next
1st.
Wednesday.
All right, so we're meeting on next Wednesday.
Yeah.
Oh, wow.
And we will tackle these first thing next Wednesday while our brains are still fresh.
Yes, sir.
All right. But I do encourage you to read them over, get a feel for them, and we'll pick it up on Wednesday. Thank you very much, folks. And do try the last, the market equilibrium problems. The last half of those questions that we begin looking at. Again, the more you practice these, the easier they'll become. Thank you very much, and I will see you guys a week from today.
Good night.
Okay, good night, guys.
Good night.
Good night, all.
Nice.
Good night.